When performing Wireway fill calculations for installations using multi-conductor variable frequency drive cable, it's important to understand how to count the conductors for derating purposes. In this case, with Belden 29500, a 4-conductor cable, each individual conductor within the cable is counted as a separate conductor for the Wireway fill calculation. This means that if you have, for instance, 50 drives, and each drive uses one 4-conductor Belden 29500 cable, the total number of conductors that you would use for your calculation would be 200, which is derived from multiplying the 50 drives by the 4 conductors per drive. Once you've determined the total number of conductors, you must account for ampacity derating due to the presence of multiple conductors in the Wireway. The National Electrical Code, or NEC, provides guidelines for this derating. When you have a large number of current-carrying conductors bundled together in a Wireway, the heat generated by each conductor can raise the overall temperature within the Wireway. This necessitates reducing the allowable ampacity of each conductor to prevent overheating and potential insulation damage. The ampacity adjustment factor, or AOF, is a value used to multiply the cable's inherent ampacity to determine the maximum allowable current it can carry in the specific installation conditions. The NEC provides tables that specify the AF based on the number of current-carrying conductors in a raceway, cable, or Wireway. In the instance provided, it is important to consult the specific NEC table applicable to your situation to determine the correct AF. However, for illustrative purposes, let's assume that based on the number of conductors, the appropriate AF is 0.8. This signifies that you need to reduce the cable's ampacity to 80% of its listed value. For example, if the Belden 29500 cable has a listed ampacity of 40 amps with an AF of 0.8, the maximum allowable current for each conductor in your installation would be calculated as follows. The maximum allowable current equals 40 amps multiplied by 0.8, which equals 32 amps. So, in this scenario, you would need to ensure that the current flowing through each conductor does not exceed 32 amps. Beyond the ampacity derating, it's also crucial to adhere to the Wireway fill requirements stipulated by the NEC. These requirements limit the amount of space that conductors and cables can occupy within a Wireway to ensure adequate ventilation and prevent overcrowding, which could lead to overheating and insulation damage. The fill percentage is typically expressed as the maximum percentage of the Wireway's cross-sectional area that can be occupied by conductors and cables. A common requirement is the 20% fill limit. This means that the sum of the cross-sectional areas of all cables and conductors within the Wireway cannot exceed 20% of the Wireway's total cross-sectional area. To calculate the fill percentage, you need to first determine the total cross-sectional area of all cables within the Wireway. This involves looking up the dimensions of the Belden 29500 cable, including its insulation, and calculating its cross-sectional area using the formula for the area of a circle, which is pi times the radius squared. Remember that you need to use the outer diameter of the cable, including the insulation, to accurately determine its cross-sectional area. Once you've calculated the cross-sectional area of a single Belden 29500 cable, you can multiply it by the number of cables in the Wireway to obtain the total cable area. Then, you need to determine the cross-sectional area of the Wireway itself. This will depend on the dimensions of the Wireway, which should be readily available from the manufacturer's specifications. Finally, you can calculate the fill percentage by dividing the total cable area by the Wireway's cross-sectional area and multiplying by 100. This will give you the percentage of the Wireway's area that is occupied by the cables. If the fill percentage exceeds the allowable limit, such as 20%, you'll need to either use a larger Wireway or reduce the number of cables within the Wireway to comply with the NEC requirements. It's important to remember that these calculations and requirements are in place to ensure the safety and reliability of the electrical installation. Overcrowding Wireways or exceeding the allowable ampacity of conductors can lead to overheating, insulation breakdown, and potentially electrical fires. Therefore, it's crucial to carefully consider all applicable codes and standards and perform thorough calculations to ensure that the installation meets all safety requirements. Furthermore, it's advisable to consult with a qualified electrical engineer or inspector to review your design and calculations, particularly for complex installations or when dealing with high current circuits. They can provide valuable insights and guidance to ensure that the installation is safe, compliant, and reliable. In summary, when working with multi-conductor VFD cables and wireways, remember to count each individual conductor when derating for the number of conductors. Apply the appropriate ampacity adjustment factor based on the number of conductors and the applicable NEC table. Calculate the fill percentage based on the total cable area, including insulation, and adhere to the maximum fill percentage requirement for the wireway. By following these guidelines and consulting with qualified professionals, you can ensure a safe and reliable electrical installation.